Okay. So, ladies and gentlemen, what I'm going to do is I don't want to scare you too much. Sadiq? Okay. I don't want to scare you too much, but I'm going to kind of go back to graphing real quick, okay? All right.
No! Next you're going to tell me there's fractions in this group.
And also with fractions, or not with fractions, we're going to go back to those lovely numbers that we didn't understand, which were imaginary. Okay, now, shh, listen up, please. I really need you guys to make sure you guys can fully have an understanding of this. So the first thing is, let's go and have those 4 graphs kind of written up there. That's fine. So let's draw those 4 graphs up there. And ladies and gentlemen, what we're going to go back to do is we're going to go back and talking about the roots. All right? And if you guys remember, the roots, well, a lot of times what we related on graphically were the same as the x-intercepts of your parabola. All right? So remember we talked about you had your roots of your equation. So you had your roots of your equation, which we related to our x-intercepts of our graph. Now, there's a couple different scenarios we talked about. Right? When we talked about solving, there was like no solution, 1 solution, or 2 solution. So let's go back through that again and kind of see exactly where those are at. So the first one, let's talk about when we have 1 solution. So 1 solution, what you're going to have is your vertex of your graph is going to exactly touch the graph, or your x-axis. So when it just touches the x-axis, what you're going to have is 1 real root. I don't know why I put a dot over my 1. Okay, so that is an example of 1 real root. Now, the next type is the more common that we used in this class was when we had to factor or solve and we got rational numbers. They could be fractions or they could be whole numbers, but they were rational. So an example of that was like we found the answer 1, 2, 3, 4, 5, 6. To find our answer to be -2 and 6, right? So we said x equals -2, x equals 6. And those were pretty easy to find because we could factor those, right? Do you remember we could solve by factoring? So when we had rational roots, what we had is we had 2 roots, though. So here you have 2 real roots. So that was an example of 2 real roots. Then we got into also, if you guys remember, there was that problem where I told you guys to approximate, right? We had the root wasn't exactly on a whole number or on your graph. It wasn't on an integer part. So we had to approximate. And a lot of times what also you'll come into, if you guys remember when we were doing completing the square, do you remember getting like x equals the square root of a number? Remember some of those answers? We had to leave our answer in square roots, right? We did some of those problems yesterday where you had a square root of an answer. So that's very possible as well. And I don't know, let's just do, let's pretend I'm going to have a problem. And let's say my roots are x equals plus or minus the square root of 2. Okay, so let's pretend my graph doesn't have, the roots are not positive. I'm sorry, the roots are not real. I'm sorry, they are real, they are positive. But my roots are not rational. I cannot rewrite them as a fraction. So these are what we call 2 irrational roots. Huh? I'm just approximating my graph right now. I'm going to show you what to, I'm just kind of approximating that's what it looked like. Because then the last one we talked about was imaginary roots, right? And when you have imaginary roots, what that means is the graph is not actually going to cross your x-axis. And so we said imaginary roots, look something like this. But we could still find the roots, right? We could still solve And what did we just got? Instead, we just got what? We just got an I with the problem, right? If I said, x squared equals -9, can you still solve this quadratic? Yeah, you take the square root, and you got x equals plus or minus 3i. So what that means is the roots are plus or minus 3i. But 3i is not on that x-axis. Make sense? OK. So ladies and gentlemen, what we're going to do is we're going to do a little cheat sheet. OK? I'm going to give you guys a little bit of a trick that you can always do to determine what your answer is going to be. Because we have learned a lot of different ways to solve for a problem. We said you could graph it. We said you could factor it. You could do completing the square. You could solve by square root method. You could solve by inverse operations. There's a lot of different ways we learned how to solve for x. And one way what we're going to do is we're going to learn kind of a way to think about what your answer is going to be. It could be either one of these possible solutions, right? Right? You could have it be possible one of these. These are your 4 options. You can't have any other extra options on. So what we're going to do is I'm going to show you guys how to determine what it is. So what you're going to do is you guys need to remember your ax squared. Ax squared plus bx plus c, right? That's whenever you have a quadratic expression here. It's not an equation or a function. But if you have your quadratic, what we're going to do is what we're going to call, it's called the discriminant. Okay? And you're going to want to write this down. So your discriminant all your discriminant is taking b squared minus 4 times a times c. Okay? And the discriminant is going to be very, very helpful in helping you determine what your graph's going to look like. And for all quadratics, you can always find the discriminant. If you guys remember we're graphing, I said, hey, find the axis of symmetry, right? That's the first thing you should always do. The same thing with when you're trying to graph a quadratic, if you guys can find the discriminant, it's going to help you understand exactly what your problem is going to look like. So here's what we're going to have. Here's what we're look at. So when you have one real root, here's what your answer is going to be for your discriminant. You're going to have b squared minus 4 times a times c is going to be greater than 0. Well, actually, when it's going to be one real root, you're going to have b squared minus 4 times a times c is going to be, equal to 0. When are you going to have 2 real roots? 2 real roots is you're going to have b squared minus 4 times a times c. That is going to be greater than 0. And b squared minus 4 times a times c is a square number. And do you guys remember your square numbers? 4, 9, 16, 25, 36, 49, 64, 81, right? So whenever your discriminant is positive and it's a square number, you're going to have 2 rational roots. What about when you're going to have irrational roots? And. Yes. For it to be irrational roots, you're going to have b squared minus 4 times a times c has to be greater than 0. Has to be greater than 0. Yes. Yes? b squared minus 4 times a times c has to be greater than 0. And also, b squared minus 4 times a times c is not a square number. So that means all the numbers that are not square. 1, 2, 3, 5, 6, 7, 8. All non-square numbers. Huh? Right. So you could have your, well, what would square root of 1 be? Square root of 1 would give you 1, right? So that actually would simplify in to give you some real roots as well. 1 you could add in your square numbers as well. Because 1 squared, very good. Yeah, so 1 would work as a square number as well. Now, lastly, we're going to look at is when are we going to have our negative? When are we going to have our complex? And this one's pretty simple. All you guys are going to have complex is when b squared minus 4 times a times c is less than 0. I don't care if it's a square number or not. But whenever you have b squared minus 4 times a times c, you know your roots are going to include I, or your imaginary complex numbers. OK? So let's recap on what we've kind of gone over with this. We talked about the roots. We talked about the roots of a parabola. There's 4 different ways you can have it. You can have 1 real root. You can have 2 rational roots. You can have 2 irrational roots. Or you could have complex roots. Now, how can you determine that besides factoring, right? Because look at guys. Here, you can probably factor this. Here, you could probably factor this. This is probably going to be really hard to factor. You're probably going to have to do completing the square. This could be factorable or by using completing the square. All right? But it's going to take a lot of work. If you guys, all you got to do is square a number and subtract it by 4ac, right? That's not that bad. You guys can quickly doing it by knowing what your quadratic form is. And then you guys can find the rest of the work. All right? So I have 3 problems up there on that sheet of paper. What I'd like you guys to do is go ahead now and see